Hello and welcome to a digital lecture for Salt Lake Community College. This lecture will be the first to cover section 5.1 for Intro to Statistics, considering relationships between variables. For some time, we have been focusing on a single variable, but it is often the case that we wish to analyze the level of influence one variable has on another, which is why this entire chapter, starting with this section, covers inference for two categorical variables. We call variables independent when they are not associated, which means that there is no evident relationship between the variables. These two options are mutually exclusive from one another. Variables are either related in some way, which means associated, or not, which means they are independent. No pair of variables is both associated and independent. The trick will be how we determine that variables are related or not, though we will really tackle the methods therein in later lessons. We want to label the two variables in question as either response variables or explanatory variables. A response variable is the variable of particular interest in the study or the outcome of the experiment, whereas the explanatory variable is the variable that we suspect may affect the response variable. Note that we say that it may affect the response variable. We sometimes also say that it may explain the response variable. As shown below, to identify the explanatory variable and the response variable in a pair of variables, think about what direction makes the most sense between them. We say that the explanatory variable might affect the response variable. So when looking at a situation, try to think which one is being measured and focused on, which is the response, and which one we are simply using to adjust or vary to get possible different results, which is the explanatory variable. You will see a few examples of these on the next page. However, before we get to that, we want to caution against using the tangential terminology of cause and effect, although they may seem similar. Specifically, we label variables as explanatory and response because this does not guarantee the relationship between the two is actually causal, even if there is an association identified between the two variables. We use these labels carefully only to keep track of which variable we suspect affects the other. Keep in mind that we are not guaranteeing that there is a cause and effect relationship. This is why we do not label these as cause and effect variables. We will actually go into in further lessons which type of studies we will have that can help determine causal relationships, and what kinds of studies will not. Using the terminology of explanatory and response is far more general and far more accurate when trying to describe situations in all types of studies. Let's go to the next page and see some examples of these. First, we have, is there an association between daily coffee consumption and the occurrence of skin cancer? Researchers asked 93,676 women to disclose their coffee drinking habits and also determined which of the women had non-melanoma skin cancer. The researchers concluded that consumption of 6 or more cups of caffeinated coffee per day was associated with a reduction in non-melanoma skin cancer. We are first tasked to find the response variable and the explanatory variable in the study. Keep in mind that the response variable is the one that we are focusing on, whereas the explanatory variable we're trying to see as the variable that explains the result that we get, the response that we get. In this case, what the study is trying to analyze is the level of non-melanoma skin cancer. And they're trying to see how the effect of coffee has on that. Or what is the association between coffee and non-melanoma skin cancer. What we're trying to say here is that the response variable is the occurrence of skin cancer, whereas the explanatory variable, the variable that we are trying to see helps explain the level of non-melanoma skin cancer, is the coffee consumption. it would make less sense in this case also if we were trying to go the other way around, saying that the occurrence of skin cancer influences the level of coffee consumption. Second, we're trying to identify some of the potential confounding variables in the study. Now, recall from Chapter 1 that confounding variables are associated with both variables, but not actually measured in the study. This means that these are variables that may not be explicitly stated, and oftentimes are not until the discussion phase of many studies. However, there's sometimes even studies that the researcher may have forgotten about. Maybe it's a variable that's sitting in the background that may influence both of these. And there tends to be a lot of these types of variables. Specifically, we could think of things such as age that could influence both how much coffee they drink per day and non-melanoma skin cancer, or maybe a genetics type of thing. Maybe that determines how much coffee they drink per day. Maybe it was something passed down through the family. And also, maybe non-melanoma skin cancer is more common in one family over another one. So there are many types of confounding variables you could think of. Some that I thought of were age, overall health, or even genetics. Lastly, can we conclude drinking 6 or more cups of coffee causes a reduction in the chance of non-melanoma skin cancer? Keep in mind that that word that's used in that sentence there, causes, is very dangerous. We have a hard time trying to determine if there is an actual causal relationship between one variable and another one. We say that we cannot determine a causational relationship with this observational study. We can only say that there is a possible association between the two variables. If you have any further questions, be sure to review the example videos or ask your instructor.